Hi guys, Assalamu alaikum. I hope you're all well and having a good day. Your favorite physics instructor Shubra Ahmed is back again with another paper solving video, which is the most recent Physics Unit 3 paper, the January 2025 Physics Unit 3 paper, which we will solve today in detail. So without wasting any more time, let's start. A student investigated how the acceleration of a toy car on a ramp depends on the angle theta of the ramp. So basically, this is the angle theta of the ramp, and the more the theta increases, the more slanted the ramp becomes, right? So the more will the car accelerate. This is the main concept that they are trying to judge. She placed a light gate connected to a data logger near the bottom of the ramp as shown. So basically, why did he connect this data logger with the light gate? Because the data logger will measure the time it takes for this length of the toy car to pass through it. This is basically kid stuff, something that we have learned in our O levels as well. Now, the later part of the question, it says, as the toy car passed through the light gate, the longest part of the toy car interrupted the light beam. And when it interrupts the light beam, at that time, it starts the clock or it starts the timer. And then the time it takes for this length to actually pass through the light gate is measured, the time taken. And that time is used to calculate the velocity, something that we will look after in the later part as well. And the next part, it says the data logger recorded the time for the toy car to pass through the light gate, something that I have said to you guys previously. The next part says the student measured the length L of the toy car using digital calipers. Determine the percentage uncertainty in the measurement of L. So basically, this question was a bit tricky. It was tricky in a sense that most of the students who attempted this paper in the Jan 2025 exam actually didn't know the resolution of digital calipers. Okay, they knew the resolution of meter rule, vernier caliper, or micrometer screw gauge, but they didn't know the resolution of digital calipers. That's why they messed up in this question. Okay, so basically that's why you guys will have to be able to understand or memorize the resolution of the digital caliper. Now let's have a look at the resolution of the digital caliper. We know the resolution of a digital caliper is actually 0.1 millimeter. This is the resolution of the digital caliper. Now the question arises, why we'll actually use the resolution of the digital caliper? Because we know the formula of percentage uncertainty is half resolution divided by average measured value into 100%. And we know our half resolution will be 0.1 divided by 2, which will become 0.05 divided by the average measured value, which will be 75.6 millimeter, and both of them are in millimeters, right? Into 100. So this will give us a value of 0.066%. So this will be our value. Okay, this is the value that they have given us, and we will answer it in one significant figure by writing 0.07%, nothing else. Okay, we'll give the answer in one significant figure by giving it in 0.07%. All right, so now moving on to the next part, it says the student adjusted the ramp so that theta is equals to 20 degree. She released the toy car from the top of the ramp and recorded T from the data logger. She repeated this several times as shown in the table. Determine the mean value of T. Now this is another kid stuff, something that we have learned in our class 6 or 7. To calculate the mean, we will add all of these values and divide it by the number of values, right? So here we have, if we add mean, so mean is going to be equal to 44.7 plus 44.6 plus 44.9 plus 45.2 plus 44.5 divided by 5. Why we will actually divide it by 5? Because there are 5 different values, right? And if we divide them, we will get our value as 44.78 ms, as they have calculated the time in ms. So don't forget to write this ms. Now we cannot actually keep our answer in 4 significant figures because the data provided are all in 3 significant figures. So we will write it down as 44.8. Never ever mess up in this position, because messing up in the significant figure will make you lose 1 or 2 marks in every question. So make sure you're understanding it. Now the next part, it says determine the percentage uncertainty, the mean value of t. Now previously we have seen another percentage uncertainty formula, which was the half resolution divided by average measured value. And now there is another type of question that you guys will not see in only physics unit 3 but also in physics unit 6 as well, which will also ask you to figure out the percentage uncertainty. Now in this percentage uncertainty, the formula will be half range divided by average measured value into 100%. Now the question arises, what is actually the half range? The half range is actually, they have given us a couple of values, right? They have given us 5 values. The half range will be, we know range is equals to bigger value minus the smaller value. So let's figure out the range first. Here the the biggest value here is, what I can see is 45.2 is the biggest value, and the smallest value is 44.5, right? So we can say 45.2 minus 44.5. This is what the range is. Bigger value divided by the smaller value. Sorry, bigger value subtract bigger value minus smaller value. But the formula says it should be half range. So we have figured out our range, right? Now we will actually divide it by 2. Then we will get our half range. So our value here will be, our half range value will be 0.7 ms. Now we will just have to do what? We will actually use this half range value divided by the average measured value. The average measured value means mean also means the average, right? So we will write this mean value into 100%. So it will be 0.7 ms divided by 44.8 ms. Sorry, my bad, actually there was a mistake. This 0.7 was actually the range. Okay, this 0.7 was actually the range. Let's not divide it right here, let's divide it in the later portion. Okay, 0.7 was actually the range. Now we will actually divide it by 2 to get our half range value, which will be 0.35, right? Which will be 0.35. Now we will use this 0.35 right here. So we know our half range value is 0.35 divided by the average measured value, which is 44.8 into 100%. So our actual percentage uncertainty value will be 0.78. Okay, our value is 0.78, and I will give our answer as 0.8%. So 0.8% is going to be our correct answer for this question. Now moving on to the next part, it says describe a method the student could use to determine the acceleration of the toy car. Now for this situation, which we can see right here, we cannot use s is equals to ut plus half at squared, right? We cannot use s is equals to ut plus half at squared, because we are going to figure out the final velocity right here, because the final velocity is this velocity. This is actually the instantaneous velocity, which can also be regarded as the final velocity as well. Okay, we cannot use s is equals to ut plus half at squared. Now the formula that we will be using right here will be v square is equals to u square plus 2as. V square is equals to u square plus 2as. This is the formula that we will be using. Now it is coming from the rest, right? The toy car was at rest, so we can say our initial velocity is going to be 0. Now let's talk about the final velocity. Now here our final velocity is going to be this velocity at the bottom, the velocity that we will figure out. How we will actually figure out the velocity? We will actually figure out the velocity because we know velocity is equals to distance divided by time taken. Now here the distance will be the length of this toy car. The distance will be the length of this toy car divided by the time it takes for this length of the toy car to pass through this light gate is will be our time. So using this we will get our velocity value. Now it remains only the displacement. Now the displacement will be the displacement it takes from the starting point till the light gate. This will be our displacement because this is the position only where he will accelerate, because at the bottom there is no more acceleration. Okay, and using all of these we can easily figure out our acceleration value, right? So now our answer will be like this. We will actually construct them like this. We will actually construct them like this. We will measure the distance s between the starting point and the light gate, because this is the position where it actually accelerates. Then we will calculate the speed of the car to the light gate using length divided by mean time. Okay, we will use this mean time. Okay, we will use this mean time. It is important to mention this main part. Then we will use v square is equals to u square plus 2as to calculate the acceleration. So this is gonna be our method to determine the acceleration of the toy car. Hopefully you guys have understood it completely. Concrete is often used to make supporting beams in buildings. Strands of a material can be added to the concrete mix to produce fiber reinforced concrete. Okay, so basically we will reinforce fiber into this concrete. A student had some small beams of fiber reinforced concrete. Each beam has the same size. He placed the beam across two supports as shown. So basically there are two supports, on top of it the beam is, right? Describe a method the student could use to determine an accurate value for the maximum force a beam can support. So this line is very important, the maximum force that the beam can support. Should include the use of any additional apparatus needed. All right. So basically, to determine an accurate value of the maximum force the beam can support, that means the maximum force that the beam can endure before breaking, the maximum mass or the maximum weight that the beam, as they have mentioned about the force, we can say the maximum weight that the beam can endure before breaking is what, how much he can support, right? So basically to measure this we will have to put some mass in the middle of this concrete, right? In the middle of the concrete we will have to add mass. We will place mass of, we will place mass on the beam in the middle, and then we will increase this mass. We will time by time we will increase this mass, and then as we are increasing the mass we will write them down. Let's say we have increased 10 plus 10 plus 10 kg. After including them we will multiply it with 9.81 or g to calculate the weight, right? To calculate the weight we will actually use W is equals to mg to calculate the maximum force, because weight is the maximum force that this that this concrete beam can support, right? And then we will repeat the same experiment with other beams to calculate how much it can actually endure before breaking. We will keep on adding this masses until it breaks, and when it will break we will know how much mass it can endure, right, before breaking. Let's say this is 30 mass that this is 30 kg mass that he can endure before breaking, and when you add 31 kg of mass it breaks. So we can say 30 kg is the maximum it can endure. So we will multiply 30 into 9.81 to get the maximum force that the beam can support, right? And we will not only do this experiment with only one beam, we will repeat the same experiment with a couple of beam to calculate the average value or the mean maximum force, mean accurate value. To they have asked about the accurate value, so to get the accurate value we will repeat the experiment with a couple of different beams as well. Not a different beam actually, couple of same beam, but we will repeat the experiment a couple of times. Okay, Now let's have a go and answer this question. Now our answer will be this one. So our answer is going to be that we will place the mass in the middle. Then we will increase the mass until the beam cracks. We will calculate the maximum force on the beam at breaking using W is equals to mg. And then we will repeat with other beams and we'll calculate the mean maximum force at breaking. Or we can also repeat with smaller masses when beam is close to breaking. Let's say when it is close to 30, let's say it will break at 30.2 kg. So at that, after 30 we will increase the mass by 0.1 and then 0.2, like this. So we'll be able to get the more accurate value of the mass at which it actually breaks. So you can use either of this way, but I will prefer you guys to write this in this way: repeat with other beams and calculate the mean maximum force at breaking, rather than this one, because it is tricky to understand or tricky to actually get the marks out of it. Okay, so this is more of a regular mark scheme point, so use this one. Now the next part, it says identify a health and safety issues with your method and how the issue may be dealt with. Now the first thing that comes to my mind is, let's say you are adding masses again and again and again. Now if it breaks and suddenly this beam is, let's say the beam has fallen on your hands or feet, so it can actually let's say it has broken and one of the pieces go and hits your hand or feet, so it can actually um, blow you, right? So what we can do is we can ensure that our feet or legs are not below this experiment, it is actually away from the experiment, so that we can save our feet or legs. And the another thing that can happen is when we're adding masses again and again, one piece can actually shatter and suddenly it can enter your eye or it can hit your eye. So to save your eye, what we can do is we can use an safety goggles, right? We can wear safety goggles. So this is what comes to my mind. So this is going to be our correct answer, that masses could fall and injure feet or legs or hands. So we can ensure that our feet or legs are not below the experiment. And the another thing that we can do is the beam could shatter and pieces can hit the eye, so wire goggles to protect it. I have given 4 points. You can write either these two or actually these two. I have given another exam because this is a 2 marks question, but I have still given 4 points so that you guys can know more, 2 more points, because it's important to understand the scenario, right? The next part says the student repeated the experiment using beams that contained different masses of reinforcing fibers. The student results are shown in the table. Calculate the recording of, criticize the recording of these results. Now while criticizing, you should always look after how many times one of the values were repeated. Now for the mass 2, when for 2 gram mass, it wasn't repeated even once, right? It was only the experiment was done only once with 2 gram mass of fiber. With 2 gram mass of fiber beam, a beam which contains 2 gram mass of fiber was experimented only once. There is no repeat readings on any of them, right? 2, 4, 5, all of them were actually experimented only once, so repeat readings were necessary. And the another thing is, what we can see is the maximum force values, it is 2 significant figure, it is also 2 significant figure, but here it is 3 significant figure and it is 4 significant figures. So basically there are inconsistent significant figures, whereas the values should be consistent significant figures. So this is the two things that we can actually criticize them, right? So we can write that no evidence of repeats and inconsistent numbers of significant figures for maximum force. Now the next part, it says the student concluded that the increase in maximum force was proportional to the mass of fiber in the beam. So the maximum force that this beam can endure was increasing. Let's say one beam can endure 10 kg and the other beam can endure 12 kg. Now the beam that can endure 12 kg has, let's say, 5 gram of fiber in it, and the beam which can endure 10 kg has, let's say, 3 gram of fiber on it. Um, as the mass of the fiber in the beam increases, the maximum force it can endure or it can support also increases. So this was proportional. As they have said it was proportional, so we know whenever something is proportional, if we draw a graph of, let's say, maximum force against the mass, we will get a straight line through the origin, right? Because this is what directly proportional or proportional means, right? So we can simply tell like that we can draw a graph of frictional force and mass, and then we will see that graph should produce a straight line through the origin. So basically this is our answer. We will calculate the increase in maximum force and plot a graph of this against mass, and then the graph should produce a straight line through the origin. Okay, and then before we should actually calculate the maximum frictional force by giving the mass, by multiplying the mass with the gravity. Or you can also use a force meter as well. As the question suggested, you should include an additional apparatus. You can also use a force meter. Rather than saying we will calculate, you can also say we will use a force meter to calculate the maximum force. Okay, you could have also written that as well. The mark scheme also accepts that particular point. The question number 3 says a student investigated how the change in position of the sun in the sky affects the power output of solar panels. These are some of the questions that these are the type of questions that we have seen in our physics unit 2 as well, right? She fixed a small solar panel angle to the horizontal. She used a lamp with an adjustable stand to act as the sun, as shown. By changing the angle theta, she modeled the change in the position of the sun in the sky. All right. One of the solar cells in the solar panel was connected into a circuit. The circuit also contained a 10 ohm resistor, an ammeter, and a voltmeter as shown below. All right. The investigation is affected by background light. All right. We are actually figuring out the light from the sun, right? How much light, or the efficiency of, actually how much light is incident on the solar panel, and then we will measure the efficiency of the solar panel, right? So this is something that we are measuring. So if there is any background light, then we will not be able to understand the efficiency of the solar panel, because this is the energy input that we want. We don't want the energy input from any other source, right? So suggest what the student should do to control the background light during the investigation. He can simply carry out the investigation in a dark room, right? He can simply carry on the investigation in a dark room, which will not allow his energy input to be altered. Okay, the energy input, there will be no other energy input rather than the sunlight. Suggest two other variables that the student should control during this investigation. The few more things that he should be controlling. Now, the one thing that only comes to my mind is, while doing this investigation, the distance from this lamp, let's say, the distance from this lamp to this solar panel, this distance should always be constant. The distance from the solar panel to the lamp should always be the same. Okay, the distance from the solar panel to the lamp should always be the same. And the another thing that should be maintained is this voltage, this ampere, and this resistor. Basically, the power supply of the power circuit, or the power supply of the circuit. Okay, or we can say the power of the power supply. The best thing is the power of the power supply should be the same. The power of the power supply should be the same. And another thing is the power of the lamp should be the same as well. You are making difference in the theta. He was changing that angle theta, but he should make sure that the intensity of the lamp is the same, or the power of the lamp is the same. By keeping the power of the lamp same, by changing the theta, he can measure how much efficiency it is coming, right? So this is what he can do. So the two words that will be right there will be the power of the lamp should be the same, and the power of the power supply should be the same, as well as distance between the lamp and the solar cell. So I have given actually 3 different reasons. You can use any 2 of them, because this is a 2 marks question. and it's better to memorize all three of them, because you never know, in the next exam paper they might give this question as a 3 marks question, so you should be able to answer it at that time, right? Now in the next part it says the student used a light meter to determine the power input of the light incident on the solar cell. Okay, she determined the angle theta for each position of the lamp. Alright, so each angle she measured the current and potential difference of the solar cell. She calculated the output of the cell at each angle. She also calculated the percentage efficiency of the arrangement. Her results are shown in the data value. The question says calculate the missing values of P out and the percentage efficiency. Alright, so basically we will have to figure out the power output. So the power input was actually from the lamp, and the power output was on the solar panel when this circuit was, let's say, working, right? The solar panel. So the power input was the power from the bulb. Now this power output will be the summation of the voltage and current from the um, from the power supply, right? Or the, not the power supply actually, the voltage and the current on the circuit, right? So we will multiply these two to get this power output value. So it will be 0.536 into 22.24. Power output is going to be 0.536 into 22.24, and our value will be 11.9. So our value is 11.9. All right, and we'll also have to figure the efficiency, and we know the formula of efficiency: power input and power output will be there. So percentage efficiency will be, we know power output divided by input. Our output is 11.9 divided by the input right here is 46.1 into 100%, right? So our value right here will be 25.8%, and make sure your significant figures are absolutely the same as the question. So basically we are done with this part as well. The student plotted a graph of efficiency against theta. So in the y-axis you guys can see they have given the efficiency, and in the x-axis they have given us the theta. Now the next part of the question says determine the maximum efficiency of the arrangement for the corresponding angle theta max. So basically they have given us a lot of points. We will have to draw a curved line on these points. So this is how we will be actually drawing the curved lines. And after we are done with the curved lines, we will have to figure out the maximum efficiency of. So now let's take the maximum efficiency value first. Okay, let's take the maximum efficiency value first. So basically this will be our maximum efficiency value, and now let's take the maximum theta max corresponding to this maximum efficiency value. So basically this is our maximum efficiency and the maximum theta max value. This one is 29.6. This is a maximum efficiency, and at 29.6 maximum efficiency, our maximum theta value is 55 degree, right? So we can easily write this down as 29.6 and the 55 degree. So this is how our answers will be. Now they have accepted answers from 29.6 to 29.8. So if your answer is within this range, you are correct. And from 55 to 57, if your answer is within this range, then you are correct. The part C says explain how the student could collect more data to increase the accuracy in her value of maximum efficiency and theta max. So to make this maximum efficiency and theta max more accurate, what he could do is, you guys can see one thing, that there is only one data right here and there is one data right here, but there is no data in between the maximum efficiency value. Where it actually is going to be, to figure this out, we can actually add few more data into this position, right? So the student can actually measure more data in the top of the curve, right? In this position he can take more data, or the best possible way to say this will be around the peak of the graph, around the peak of the curve he can take more he can take measurements of more values around the peak of the graph, so that more accurate values can be calculated, right? More accurate values can be calculated. Now for more accurate values can be calculated, we need more values in this region, right? In the peak of the graph we need more values. So to get more values or more values in this, we can say these values corresponds to these values, right? These values are corresponding to these values. So we can say we can take theta values from, let's say, from 52 to 56. This is the region where we can take more theta values, right? This is what we can say. Now let's have a look at the answer right here, what the answer will look like. Okay, now here the answer says we will take voltage and current measurements. We will take voltage and current measurements for smaller angles. Why for smaller angles? Because we know 55 degree is the angle at which the maximum efficiency has occurred. So now we will take values from, let's say, 52 to 61. We will take more measurements in this region, because this region corresponds to this region as well, right? So we can say smaller angles means 52 degree to 61 degree. Okay, around the peak of the curve, around this peak of the curve, this theta value corresponds to this peak of the graph, right? So if we take more values in this peak of the graph, we will be getting a more accurate value. And third point is so that the peak of the curve can be determined more accurately. Now, one question might arise in our mind: why we are taking voltage and current measurements? Because these voltage and current measurements is our actual power output, and we need that power output to figure out the efficiency, right? This efficiency corresponds to this efficiency right here. The formula of this efficiency is power output divided by input. Now input is absolutely constant, but to figure out the efficiency we need this power output. That's why rather than writing take power efficiency for smaller angles, we have written take voltage and current measurements for smaller angles, because the efficiency mainly depends upon the power output. That's why we are taking the voltage and current into consideration rather than directly writing take efficiency measurements for smaller angles. We have said take voltage measurements for smaller angles around the peak of the graph, and also so that the peak of the curve can be determined more accurately. Now let's head towards the next question. It says the student only moved the lamp vertically in her investigation. Okay. During the day, the sun moves vertically and horizontally across the sky. State the direction in which the light should be incident on the solar panel for maximum output. This is a typical physics unit 2 question. We know when the solar panel and the sun is at 90 degree, I mean the sunlight is at 90 degree on the solar panel, maximum output occurs, right? This is something that we have seen in our O levels as well. Maybe not in O levels, actually in our physics unit 2 as well. So this is the exam. This is the answer, that the light should be incident at 90 degree or perpendicular to the panel to make sure that maximum output occurs. To make sure that maximum output occurs, we can actually do this thing, right? The light should be incident at 90 degree or perpendicular to the panel. Now the next part says the solar panels at a solar power station are mounted on motorized stands. Okay, it was mounted. All right, so we have made a change. Explain how this could increase the energy generated during a day. So now we'll have to explain how it will increase the energy generation. Now let's think it of like this. Okay, now it was mounted because we know that at 90 degree, maximum output occurs, right? Maximum power output occurs at 90 degree. So it was mounted definitely for a reason, to maximize the power output, right? It was mounted according to the, or relative to the position of the sky. It was mounted in such a position, with relative to the sun, so that maximum power output occurs. Okay, and we can also say we have mounted it just because to make sure that the sunlight from the sun is appearing or is coming or is incident at the solar panel at the best angle in which the maximum output will occur. So this is mainly the main reason. Okay, This is mainly the main reason, nothing else. So basically this is going to be our answer. The answer will be the panel could move to follow the sun's position in the sky. The thing that I've said, that it has moved, it was mounted so that it is in the base position with the side. It is in the base position with relative to the sky, or the actually the sun. We can actually say the sun. Okay, it's the better way to say sun, or you can also say the sky. The panel was mounted like this so that it is at the base position with relative to the sun, to ensure the light was always incident at the best angle to the panel. Best angle means actually close to the 90-degree angle, or at least the 90-degree angle. So the power generated was increased. So this was the main thing for which you guys will get the 3 marks. It was a very easy question. Two of the lines, the first line and the third line, is in the question. Just you guys will have to be able to answer this second line, which is it was mounted, and the reason for mounting it was to make sure that solar panel is at the best angle to get the sunlight from the sky, and the best angle is, let's say, close to the 90-degree or 90-degree. Alright guys, I hope you have been finding the video helpful so far, and you have understood each and everything till now. If you want to solve more question papers with me, or if you want to complete the full syllabus with me, you can join my high impact crash course for the October 2025 and January 2026 session. And you can also join my full course for the May 2026 A2 Physics. And regarding the AS Physics, the same for October 25, Jan 26, and May 26, you can join my AS Physics course as well. Now, let's talk about the May 2025 session. Now, for A2 Physics, we have our question papers marathon course going on for the May 2025 session. You can join our question papers marathon course to ameliorate your preparation in the last 10 days using our exclusive notes, digital resources, and FAQ sheets, common sheets, important questions list. We have over 30 previously recorded question paper solving videos of Unit 4, and same for Unit 5 and Unit 6. And for chemistry, biology, and maths, this is the same thing that we have. In order to make you guys better, we have prepared all of these things. And not only the recorded videos that you guys will be getting, you guys will also get 10 live classes to clear all your problems of the recently concluded papers, let's say from Jan 24 to Jan 25, as well as the previous papers as well from Jan 2020 to October 23. In those live classes, we'll be covering your problems. So this is how we will be making you score your desired score. So without wasting any more time, join our question papers marathon course. For more details, message us at WhatsApp number provided in the description box, and you can also message us at our Facebook page, Exam Essentials. Now let's solve the last question, number 4. A student used a source of ultrasound to create a standing wave in a narrow container of liquid. The standing wave created layers of increased density in the liquid. This causes the liquid to act like a diffraction grating, something that we have learned in our physics unit 2. The student directed a beam of light from a laser through the container. This produced a diffraction pattern on a screen as shown. Alright. The student varied the frequency of the ultrasound. For each frequency, he measured the distance of the first order image from the central maximum. So basically this distance he measured. Alright. He then calculated the diffraction angle theta of the first order image. His results are shown in the table. Now in the part A, it says complete the table with corresponding values of sine theta. So now we will actually show the corresponding values of sine theta. Okay. We will actually show the corresponding values of sine theta. So to show the corresponding values of sine theta, what you can do is you can put sine 0.052. Okay. You can put sine 0.052. Putting sine 0.052 on the calculator gives me a value of the value that comes in my calculator is a very small value, which is 0.000908, and putting this value on the calculator gives me a value of 0.00157, and also putting this value on the graph gives me a value of 0.00185. So basically putting all of these values as well, you will see that you are always getting a value like this which has 0.00 at the first. So basically rather than putting these small values right here, the only way you guys can put it right here is you guys can use another way. The way will be like this. Let's say you are getting the value as 0.00157, right? This can also be written as 1.57 into 10 to the power minus 3, right? It can also be written as 1.57 into 10 to the power minus 3. And for let's say this one 0.170, the value comes as 0.00297, which can also be written as 2.97 into 10 to the power minus 3, right? Keeping the significant figures the same, because these three all these values should have the same significant figures. So you can write this down as the same, right? So what we can do is we can write it like this: sine theta values. So for the sine theta, this value will be 0.000908. It will be 0.00157. It will be 0.00185. It will be 0.00241. It will be 0.00297, and it will be 0.00370. Now all these values are very small. Now another easy thing that we can do is we can draw another graph and we can put it like this. Now this one will be sine theta into 10 to the power minus 3. We can put into 10 to the power minus 3 for all of them. So sine theta into 10 to the power minus 3. This is one way we actually teach all our physics unit 6 students to graph their to make their graphs, and this is exactly the same question that has come in physics unit 3 as well. So this is actually a skill that you guys have to be able to acquire. Okay, so now this 0.000908 can also be written as it can also be written as 0.908 into 10 to the power minus 3, right? It can also be written like this. So we can write 0.908, because with all of the values 10 to the power minus 3 will be multiplied. Okay, and it can also be written as 1.57 into 10 to the power minus 3. It can be written as 1.85. It can be written as 2.41. It can be written as 2.97, and it can be written as 3.70. So this was basically a trick to make sure that the values are not this small, because drawing a graph or plotting a graph with these small values are very difficult. So you guys can use this simple trick to make sure that you are converting them into a more bigger value by writing sine theta into 10 to the power minus 3 in the box. Okay, and in your exam day you might need to write 10 to the power minus 5 rather than minus 3. So make sure you are counting that using your calculator and using your brain. Okay, now in the next part it says plot a graph of f on the y-axis and sine theta on the x-axis. So I will actually draw a graph of this and this on the y-axis and x-axis. F will be on the y-axis. Okay, so now let's take the how we will actually draw the graph. Okay, now the first thing that we will have to determine is how we are going to scale the graph. And if you have watched my May 24 and October 24 paper solving video, I have said again and again that your scaling should always be in the range of 1, 2 and 5. This is the range with which you should always scale. You can never ever scale with 3 or 4, because this is unacceptable and your graph will not be accurate. And this is not accepted by the Edexcel or anywhere else as well. So your plotting should be according to 1, 2 and 5. Now let's have a look at the difference in this f values. We can see here the difference is from 2.1 to 8.3. So basically there is a difference of 6, and there is more than 6 boxes, right? There are around 12 to 13 boxes. So we can take our scaling as 1, right? We can easily take our scaling as 1. We can take our scaling as 1, and we can actually take 2 boxes to cover one frequency. We can take 2 boxes to cover one frequency. Let's draw it down together first, then you guys will understand. So basically this will be our graph, which I will plot like this, straight line. And then what I will do is I will put this one as 0, and this one as 1, this one as 2, this one as 3, this one as 4, this one as 5, this one as 6, this one as 7, and this one as 8. As I have covered more than half of the graph, it's completely all right, it's not an issue. I can also take 9 as well, because the value wasn't absolutely 8, it was 8.3, so I will need a value of 9. So this is how I have plotted my graph on the y-axis. Now let's think about the x-axis. Okay, now let's think about the x-axis. And so this is basically how my x-axis will look like. All right, so now let's take the scaling of the x-axis. Now let's take the scaling of the x-axis. Now in the x-axis, I will have to first figure out the difference between them. I can see the difference is from 0.9 to 3.7. The difference is from 0.9 to 3.7. So basically they have a difference of um, 2.8, or you can also say they have a difference of, yeah, it's actually 2.8. They have a difference of 2.8. So it's a very small difference. It is a very small difference. So I can take actually the scaling of 5. I can take a scaling of 5. Scaling means actually scaling of 1 to 5, right? I cannot take 1 because this is very small. So what I can rather take is I can take 5. I mean, I can take 0.5. You can take 0.1, 0.2, 0.5, but you can never ever take 0.3 or 0.4. This is the ruling, okay? You can take anything of 1 to 5. 1 to 5 means you can take 10, 20, 50, or 100, 200, 500, or 0.1, 0.2, 0.5, but never ever can take 0.3 or 30 or 3, okay? So we can take 0.5 as our scaling. We can take 0.5 as scaling, because 2.8 into let's say 2 will give us 5.6, right? So if we take 0.5, we will get 5.6 values, or around 6 values. So we can take it down. So here we can take it down as 0.5, this one as 1, this one as 1.5, this one as 2, this one as 2.5, this one as 3, this one is 3.5, and this one is 4. Actually it was not correct. So this one is 4. So this is basically how we can take it down. Now let's plot it down. We know for for 0.908, okay, another thing that is to actually write this down. Okay, you can have to write this down in the y-axis and the x-axis. In the x-axis we'll be writing like this: sine theta into 10 to the power minus 3. Don't forget to write this 10 to the power minus 3, otherwise you will lose most of the marks. And also in the y-axis you will have to write the frequency part. We'll be writing like this. We will be writing like this: frequency, or you can like just write this: frequency slash megahertz. Never ever forget to write the units, okay? Otherwise you will lose a lot of marks. Now let's plot the graph. So for 0.908 it will be 2.1 for the first value, right? And make sure you remember that sin theta is on the x-axis. So 0.908 and 2.1. Now here you guys can take, for you guys can see for 0.5 there is 10 boxes, right? So you'll have to take each boxes as, you will have to take each line has 0.25. So if this is 0.5, then this is going to be our 0.75. All right, this is going to be our 0.75. And sorry, my bad, it is not going to be 0.25, it is going to be 0.05. 0.25 will be between the boxes and 0.05 will be between the lines. So this will be a this will be a 0.55, this will be a 0.6, this is 0.65, this is 0.7, this is 0.75. So that, like that, if this is our 1, then this is going to be 0.95 and this is going to be 0.9. So basically this is our 0.9, and for 0.9 it was 2.1, right? For 0.9 it was 2.1. So for this 0.9 I will have to draw a 2.1 line. So this is our 2.1. This is our 2.1, and always make sure you are not putting dots rather than crosses, okay? The next value is 1.57 and 3.5. So 1.57 means if this is our 1.5, this is going to be 1.55. So it is in between 1.55 and 1.2. So it is between this line and this line. So we can take right here, okay? We can take a dot right here. So 1.57 and it is 3.5. So 1.57 and 3.5 will be somewhere right here. And we'll also have to dot across here as well. We'll draw across. Then it is 1.85 and 4.3. 1.85 and 4.3. So if this is 1.75, this is 8, this is going to be a 1.85. So for 1.85 it is going to be 4.3. 4.3 means it will be somewhere this, if this is 4, then the 4.3 will be right here, and 1.85, so it will be right here, right? This will be like this. This will be 4, 4.1 and 4.3. And if this is 1.75, this is 1.80 and this is 1.85. Because each from 1.5, if this is 1.5, this is 1.75 and this is 2. 0.25 between each boxes and 0.05 between each and every lines. Now for 2.41 it will be 5.4. So we can say 2.4 and 5.4. So 2.4, if this is 2.25, because this is 2 and this is 2.5, this will be a 2.25. This will be a 2.3, this is 2.3 and this is our 2.4. This is going to be a 2.4. For 2.4 it was 5.4. So 2.4 and 5.4 will be somewhere, if this is 2.25, this is 2.3, this is 2.35, this is 2.4. So our line is going to be right here, because this is our 5.4, right? This is our 5.4. The next line is 2.97 and 6.8. So this is 2.75, this is 2.8, this is 2.85, this is 2.9, this is 2.95, and 2.97 is in between 2.95 and 2.3, which is basically right here in the middle. It will be basically right here. So for 2.97 it was how much? It was 6.8. So 6.8 value is somewhere right here, and we know it is 2.97, so it will be closer to the 3 value. So it will be like this, right? Closer to the 3 value. Now the next part is 3.7 and 8.3. So 3.7 is going to be, if this is my 3.75, then this is going to be my 3.7, and 3.7 was for 8.3. So for 3.7, 8.3 will be, 8.3 will be like here. It was 3.7 and 8.3. Now we have all the crosses. Now we'll have to just draw the line. So we will draw the line like this. We'll actually draw the line like this. We will actually draw the line like this. So we are basically done with drawing the lines. Now if one of the lines is outside, we will check them. Okay, we will check them. It was for 2.9, right? We know for 2.97 it was 6.8. So for 2.97 it means it will be closer to the 3 value. It will be around the 3 and it will be 6.8. So let's erase it and draw it again. 2.97 and 3.8, sorry, 6.8. So basically 6.8 was right here and 2.97. So 6.8 is basically right here and 2.97 is basically right here. So we can draw a line in between. So our line will be like this. Our line can be like this, right? We can draw a line like this, a bigger line, to make sure all of them are matching. Basically we can draw a line like this, so all of the lines are matching. Okay, one or two crosses can go up and down, it is not an issue, but make sure the number of lines that is above the um, above the straight line and the lines below the straight line is equal, because this line is a little below this straight line and this line is above the straight line. So it's completely all right if equal numbers of lines are above and below the straight line. Okay, make sure equal number of lines are above and below the straight lines. All right, so now we can move forward to the next part. It says the student derived the formula lambda is equals to v by f sin theta, where lambda is the wavelength of the laser light and v is the speed of the sound in the liquid. Explain how a graph of f against sin theta can be used to determine v. We'll have to figure out the v. Now this is a very typical and easy question where we will actually have to compare it with the y is equals to mx plus c. We will actually compare them with y is equals to mx plus c. So let's write it down again. We can also write f is equals to v divided by lambda sine theta, because f is going to our y-axis, right? So we can say y is equals to mx plus c, right? We know f is our y-axis and sine theta was our x-axis. So our gradient is going to be m is equals to v by lambda, right? So we can say m is equals to v by lambda. So to figure out the v, we will multiply lambda with the gradient. Okay, we can multiply v is equals to gradient into lambda. By this we can actually calculate it, right? We can actually calculate it using this. Now it has actually asked us to calculate the value of v. So now we will just figure out the gradient and multiply with the wavelength value that they have given us with. So now let's go and figure out the wavelength right here. Now always remember, to figure out the wavelength, always take a bigger value. Always take a bigger value to figure out the wavelength. Alright, always take a bigger value. So now what I'm going to do is I'm going to take the most biggest values right here. I can actually take this line, and then I can connect this line. Okay, I can actually make it a little smaller. I can take from this position till this position, and then I can connect both of these lines. Alright, I can connect both of these lines. Now I will have to figure out this value. So basically this value is going to be this one, right? This value is going to be this one. If this is 8, then this is going to be my 7.8. This is my 7.8, right? This is my 7.8. If this is 7.8, then what is going to be this value? If this is my y1, this is going to be my y2, right? So now let's figure out this value. This value is exactly 2. So we can say 7.8 and 7.8 and 2 is right there. And then we will have to take the corresponding values of this ones. So I will have to take these values, which will be 3.5, and this value as well. And this value is going to be, if this is 0.75, then this is going to be 0.8, this is 0.85, and this is going to be my 0.9, or you can say 0.89 as well, because it was in between. So we have got our this is our y2 value, this is our y1 value, and for this y2 this was our x2, and this is my x1. And we know the formula of gradient is equals to y2 minus y1 divided by x2 minus x1, and we know our y2 value was 7.8 minus our y1 was 2 divided by our x2 was 3.5. Why did we take this one as this one? Because this is the value for which the x2 was, right? So we'll take this as our x2, which is 3.5 minus 0.89. So using them we will actually calculate our gradient. And now if we use our calculator, let's figure out the value of gradient by using the calculator. So my gradient value comes as 2.22. So this is my gradient value. Now as I have divided frequency by this sin theta, I will also have to take one thing into consideration. The thing is, it was in megahertz, right? It was in megahertz. So as it was in megahertz, I will actually multiply my value with 10 to the power 9 hertz, right? I will actually convert this megahertz into hertz. All right, I will actually convert this megahertz into hertz. Now while figuring out the v value, I will also have to convert this nanometer into meter. So my v is equals to 2.22 into 10 to the power 9 into 650 into 10 to the power minus 9. So our value of velocity is going to be 1430 ms minus 1. So don't forget to write it here. Okay, writing the answer in the answer sheet is very important. Now this is a very easy question, something that I have explained in real detail in my May 24 and October 24 paper solving videos as well. You can watch Exam Essentials May 24 October 24 physics in 3 paper solving videos to master yourself in a much better manner as well. It says the student is told that the liquid is either petroleum, castor oil or glycerol. All right, the table shows the speed of sound in these liquids. Okay, this is the speed of sound. Estimated that the percentage uncertainty in the value of v determined from the graph to be 5%. Describe, deduce which liquid was in the container. So which liquid was in the container actually. All right, so as it has a 5% uncertainty, what we can do is, what was the values that we have actually calculated? Okay, what was the values that we actually calculated? The value that we have calculated was 1430. So if it has a 5% uncertainty, we can say we will actually, it was 5% uncertainty, so 1430 was actually 100%, right? So if something has a 5% uncertainty, we will increase this value by 5%, and we will also decrease this value by 5%. So increasing it becomes 1430 into 1.105 divided by 100. Okay, and then decreasing by 5% will be 1430 into 95%. Okay, we will then calculate these two values because it has an uncertainty of 5%, and then something has an uncertainty of 5%, we decrease it by 5% and increase it by 5%. The actual 100% value we increase and decrease by 5%. So increasing it gives a value of 1502 and decreasing it gives a value of 1359, right? So let's look at the value which is within this range from 1359 to 1502. This is 1330, so it is smaller than 1359. This is 1905, so it is bigger than 1502. So we can exclude both of them, and castor oil is actually the value. So we can say 1474 is within the range, so the liquid is castor oil. So basically that's how we are done with this whole paper.